My name is Ben Ilegbodu, and this is Navigating the React Solar System, where I'm hoping to kind of give you a grand overview of React and all of the libraries that go along with React, because React by itself is not a framework. It's not a JavaScript framework like Angular or Ember. It's just a library for rendering UIs. So as a result, you need to have other libraries to kind of put together with it so that you can build your user experiences. So I'll kind of give an overview and then hopefully point you in different directions where you can look up more information if you're not familiar with it yet. So I guess show of hands in the beginning, who's actually been developing in React? Anybody here? Kind of, one kind of? Okay, perfect. Perfect audience, so I can kind of clue you into different pieces of React so that when you do get started, you kind of have an idea of where to begin. So I tweeted out a link to the slides at my Twitter handle, BenMVP. So if you go there, you will find a link directly to these slides, or you can go to my website, benmvp.com, and I've listed it there as well. So just to formally introduce myself, like I said, my name is Ben Ilegbodu. I'm a Christian, a husband, and a father. It's a picture of my wife, Rashida, and our two daughters, Avery and Simone. We were just in Tahoe this past weekend, so it was nice and warm, yet cold at the same time, but had a lot of fun there. We live in Pittsburgh, California, so I call that the far East Bay, past Oakland, past Walnut Creek, Pittsburgh. And I currently work at Eventbrite. So if you're not familiar with Eventbrite, we're an online events and ticketing platform for conferences, races, food festivals, anything basically that has tickets that's small. Eventbrite usually supports it. And I am the manager of our front-end platform team. So the team that kind of supports all of the other feature teams in their UI development. So we don't build any features ourselves, we just built a platform. And we have been transitioning our JavaScript framework, I guess, from Backbone and Marionette over to React over the past year or so. And a lot of what I'm going to be talking about are libraries that we've been using to build up our React stack. Then lastly, I'm a huge basketball fan, love basketball. I'm originally from Houston, so I'm a Rockets fan, not a Warriors fan. But the Rockets are going to win the championship this year. I'm just putting it right there, and I'll move on. So React Solar System, let's talk about it. In the center, we have React, obviously. So everything revolves around React. So that's the first thing I want to talk about a little bit. So React has a lot of great qualities to it. The main one being that it's functional and reactive. It's different than an MVC style development. And as a result, you just kind of declare what your state is and then what you want your UI to look like in that state. And basically, you're always just changing the state as a result of UI changes. And it has JSX, which looks very similar to HTML that you can use, and leverages something called the virtual DOM so that you essentially re-render your whole UI every time the state changes, but it's intelligent and only changes the part of the DOM that actually changed in the UI instead of having to do a whole rewrite of the code. And I really like React because it has a very narrow API, so I can remember everything in my head. I don't have to go to the docs that many times to see what different methods do. So as a quick example, I wanted to do a little quick comparison between jQuery and React, since most people, if you've done web development before, you're familiar with jQuery. So jQuery is imperative. Basically, you tell jQuery and statements to do different things, respond to different things, and then as a result, you update your UI. So here I have a simple UI. Basically, click the button, increments the text field. That's all it does. And that's what the code is doing as well. So on click of the button up button, get the value or get a jQuery object of a value box being the input, and then parsing its value into a number, and then setting the value of value box to be the current value +1. So simple as that. And imperative statements are kind of how we logically think of the UI. You say, I click something, and then I want to set this value to be something else. And for simple user interfaces, imperative is a lot easier to understand and to build. But as your user interfaces get bigger and bigger and bigger, imperative ends up becoming very spaghetti code because it's all driven based upon what just happened. And you have to put yourself into certain states by user actions instead of storing the data. So if we look instead at what I call declarative React, what we do is we declare our state up here. And the state is 0. And then as a result, the user interface is a function of the state or based upon the state. So now the input field has this value here, and the button on click we call handle click, and then handle click updates the state. So the only thing that's imperative is this set state function that's right here, and everything else is declarative. So the UI, what's in render, is based upon what was stored in the state. And then as the state updates, the whole user interface re-renders, but because of the optimization that React has, the whole UI doesn't actually re-render in the DOM. So I don't have time. This is not a talk about React and how to develop in the React. It's about React plus everything else. So I don't have time to go into all the details. But if you really want to learn how to develop in React, I suggest the official tutorial on React. The first thing you want to do when you're learning how to use React is to learn how to use React. Because a lot of times if you'll go look at workshops or tutorials, they'll try to teach you React plus Redux plus inline styles and all these other things to try to throw at you. But the first important thing is just to learn React and learn React really, really well. And you can do a lot with just the library itself. And this tutorial goes through kind of all the details of how React works, the way it works, different best practices that you should use. So if you get the slides, like I mentioned, you can go to that link and find the tutorial. That's basically how I learned React. Okay, so you've learned React. The next thing you should learn is JavaScript, which seems kind of backwards, but what I'm talking about is actually like future JavaScript, ES6 if you've heard of that, ES 2015, and past that. Because the latest features in JavaScript make React development so much more easy, or easier. So there's modules now, there are classes, something called the spread operator, destructuring, like all these different things that make React development much easier. And they're important to learn because basically ES6 and React really go well together. Just a gratuitous slide that I wanted to put up here. This is an example of some React code I wrote that's using like all the latest and greatest of ES6. It's actually asynchronous code. It's using something called async functions. So up top here we see an async keyword and an await keyword. So that's like JavaScript that's about to be official in this summer. And it's also using the fetch function that's available on the browsers, and I'll be talking about that in a little bit. But just kind of wanted to show you kind of what React code can look like in ES6. I actually gave a talk last week at Facebook's React Conf about React and ES Next. So if you're interested in learning more about that and how they go together, you can watch that video in the link there if you'd like. Okay, so now we've done React, you've learned ES6. What's the next thing you have to learn in order to get good at React, so to speak? And the next thing I want to talk about is tooling. So the first tool that you should have in your arsenal is the React DevTools, and it's available for Chrome and for Firefox. So if you use Safari or you use Edge, I'm sorry, you have nothing for you there. But the tools really go into detail so you can see what is actually going on in your React app. So you can see what event listeners you have on nodes, what you have in your state, what you have in your props, makes it easy to kind of understand what's going on in debug without having to throw everything into a console log. Then the next thing you want to do is get package managers. So who's familiar with NPM? Used NPM before? Okay, good. So most of you have. NPM is like the dominant package manager. There's also Bower, which has existed. It's older than NPM, and if you use some really old libraries, they may still be using Bower, but pretty much everything's on NPM now. And then Facebook last October released Yarn, which is a new CLI on top of NPM. So it still uses NPM in terms of the package repository, but it gives a new CLI for interacting with that package for that repo. And Yarn offers a whole lot of benefits above Yarn. So it's a whole lot faster to install. So if you ever have had to do an NPM install on a repo, it can take a long time, but Yarn is a lot faster because it does things in parallel. It also caches libraries that you've downloaded before. So if you did an NPM install and then went on an airplane, removed all your node modules, and did an NPM install again, it would work because it's cached everything locally on your machine. So that really helps as well. And then if your install fails, it'll try again multiple times if you had a network glitch. So it's pretty cool that way. Now, a lot of people are now switching from NPM over to Yarn because of the performance boost you'll get. I've seen cases where in NPM something installs in 5 minutes, and in Yarn it installs in 2. So it's like that much faster. Next thing are bundlers. So you have all these different modules. You're using helper libraries with React, modules even within your React application because you're going to have different components. There are different bundlers out there that you can use. Webpack is the dominant one in the React space. Browserify has existed for a while now, but it only works in the browser, as the name says. And now there's a lot of what are called isomorphic React apps, so they render on the server in Node as well as on the client on the browser. So Browserify doesn't really work well with that, neither does Require.js. So Webpack and Rollup have kind of been the top choices, but mainly Webpack for your bundling. And there's now Webpack 2 that has a lot of new features to offer to make your applications more performant. And one of those features that I want to show and highlight is called tree shaking. So what tree shaking is that, say you have this module right here, and it's called math.js. It has 2 functions in it, square and cube. So if we remember from math, I don't know what this would be, I guess algebra, maybe geometry. The square of something is just x times x, and the cube is x times x times x. So that's in math.js. Then let's say you had a main JS down here at the bottom, and all you included was cube using the new module syntax. So you just import cube from math.js, and you use that. Normally, your bundle, when you bundled main.js and math.js, would include everything. It would include both square and cube, even though you only used cube. But now what tree shaking does is it can tell that you only imported cube, so when it creates the bundle, it'll only have cube and console.log, your actual code in there. So it's kind of an optimization. So if you imagine you're using a library and you're only using 2 functions out of the 15 that are in there, you can really see a dramatic improvement in the size of the bundle that gets generated because of tree shaking. So it works specifically with ES6 modules, so this import syntax. It doesn't work with the common JS require or AMD require syntax. So that's one thing, but that works both with Webpack as well as Rollup. Okay, so let's move on. So after that, you want to have a task runner. Has anybody used Grunt before in their task? Yeah, okay, or Gulp is kind of a newer version. as well. Yep, gulp. So that is more streamed based as opposed to task imperative based as grunt is. But there's been a lot of, how do I want to call it? A lot of backlash, I guess, or task fatigue, I guess. Build process fatigue with grunt and gulp, and now people are just using simple npm scripts. So if you've used npm and if you've had a package.json file, you can actually declare scripts in that file, which are just quick things, command lines that you want to run. So here's an example of a script section inside the package.json. Let's say I want to run ESLint, I can just run that ESLint module. Or if I have a lint command, this will run the sasslint as well as the ESLint. So it's just running some command line things. And here, down here, I'm saying yarn run validate, and then I'll call this validate script that will do linting as well as testing. And then testing does that up there. So it's just an easy way if you don't have too many complicated things that you want to do. You're just kind of trying to, just a task runner to run things. You can use npm scripts or yarn scripts because the yarn CLI is on top of the npm CLI. So if you didn't have yarn, you could just replace all those yarns with npm and it would work just the same. Okay, and I think the last one I want to talk about are static analyzers. So these help you find bugs in your code before they actually run. So the predominant one is ESLint. So that's mostly for, historically it's been mostly for style. So you want to have your curly braces on the same line or the following line. Do you want semicolons or not semicolons? Do you want spaces before parentheses or not? You can enforce all these things so there's consistency across your entire code base. But lately, more sophisticated type analyzers like Flow and TypeScript have existed. So it's kind of trying to inject types like you see in C# or Java or C++, injecting that into Java so you can have even more safety in your code so that you can make sure you're not passing a string when something expects a number or a Boolean when something expects an object. So an example of that in Flow that was developed by Facebook as well is something called flow type inference. So you could never declare any types in your code. All you do is just put this comment up here, this flow comment. It can already detect errors in your code. So in this example, I have this foo function, and I'm multiplying it by 10. So by default, Flow knows that x can only be a number, because that's the only thing you can multiply by 10, obviously. But now I'm passing a string hello world to it, and it complains, wait a second, string is incompatible with number. It inferred that it was going to be, x was going to be a number. I passed it a string. It's going to give me a warning, and I haven't done anything to annotate my code. So kind of Flow is powerful in that regard, just from the beginning, which is pretty cool. So to recap, this is what I would pick if I was trying to decide what I was going to use to build a React application. I would obviously have the React Dev tools because you always need those. Then I would use Yarn as my package manager, Webpack as my bundling, Yarn or NPM, they're kind of interchangeable at this point for task running, and then lastly ESLint for my static analysis. ESLint finds so many different issues in my code. It's really nice. So that's a lot to figure out in the beginning, if I go back in a second. And if you've never done anything with React before, it's hard to determine which one of those you should pick before you even know what those things are. And that's been kind of the backlash with React, is that you have to do so much up front in order to figure out how to just create an app. Like, you don't care about all this tooling stuff. You just want it to work. So the core React team decided that they wanted to create a CLI for bootstrapping an app. So they created something called Create React App, and you install it globally. You can use Yarn or NPM. I've used Yarn in my example. And then you call Create React App and then the name of your app. So I'm calling it awesome app because every app I create is awesome. And you go into the the folder that you just created after you've done it. So this line right here will do all kinds of stuff. It'll install things, set up things, and then finally you just do yarn start, and your app is up and running. You can start building the components. So it does use Webpack and ESLint and all the things that I've talked about as well, but it's under the hood, so you don't even know that's what's happening. You could just focus on building your app. So I've listed a whole bunch of links. If any of those things were interesting to you, further information for you to read up on. Okay, so now let's start talking about how to actually make our app look nice. And there are at least 4 ways that I can think of doing CSS styling inside of your app. The first one, and most likely that you'll use, especially if you're converting over to React, is global CSS. So here I have a React component. It's a fictitious card component, and it takes in 3 properties: title, image, URL, and message, and then renders those out in some markup there. So you have the title here, you have the image URL there, and then a p tag with the message. And I've added class names to each one of those. So if you go the global CSS route, you'll just have this huge CSS file, and then at some part inside of the CSS file, you'll have those classes defined. And you'll use something like BIM syntax or some kind of syntax to make sure that you're not having name collisions. So you'll prefix all of your classes with card because you just created the card component, and to make sure that you don't have any name collisions. Another alternative, a slightly better alternative, is to have what I'm calling component CSS. So instead of just assuming that there's some global CSS file that's going to have all of your declarations, you actually import a CSS file, and that just will bring that in. So you still have your markup as the exact same, you still have your classes there, but in your CSS now, you just have a CSS file that's just card.scss and nothing else. And you would still need to prefix your class names with the name of the component, because in the end, this component CSS is just going to get bundled up into one huge global file in the end, but at least you're declaring your CSS in separate places, just like your JavaScript components are in separate places. Then third, another option is a solution called CSS Modules. So here we're importing the CSS like we were with component CSS, except that we actually get a variable back. And this variable, this object, has references to the class names. So here, instead of saying class name as string, we say css.root. So CSS is now some kind of object. So you have css.title, css.image, css.message as our class names. So this CSS module that we're importing is giving us class names. And those are generated from the CSS. And now in our CSS, you no longer have to prefix our CSS classes to worry about namespace collisions. We just say .root, .title, .image, .message. And what the CSS modules library, the system will do is that it will automatically prefix your CSS classes for you based upon the name of the file and then a random hash for you. So you don't have to worry about namespace collisions anymore. In your code, you just write whatever class names you want, whatever makes sense for the component itself, and then out it'll generate this in the CSS, as well as the resultant markup would also have these as the class names. So that it kind of makes that connection for you. And then the last option, which became popular because of React Native, where they don't have CSS, is inline styles. So it's kind of going all the way back like 15, 20 years from when we were doing web development and putting everything inline in the style attribute. So you declare an object at the top that's going to have all of your styles that you want. So that object would have like a root property, it would have a title property, an image property, and you would set whatever CSS styles that you want inline. So it's all in JavaScript. And in React, the style attribute or style prop in React is an object itself. It's not a long string like it is in HTML. So the drawbacks, though, of inline styles, or the benefits, I should say first, before I get to the drawbacks, is that you don't have to worry about cascading style sheets or cascading styles. So you know that if you write a style that just targets divs, it'll affect all divs even if you didn't mean it to. And so you always have to worry about collisions, and you throw bang importance on things because you're trying to undo specificity. But now, with inline styles, you don't have to worry about that. But the drawbacks, as listed here, are that you can't do some of the special things that CSS allows you to do, like pseudo classes, media queries for responsive design, animations. All those things don't work with inline styles. So if you don't need to do any of those, you can use inline styles, or you have to do JavaScript to kind of recreate those. So more resources for you there. Okay, and then next, sorry, I want to talk about is single page apps. This is kind of the last step in terms of building your full-fledged apps. And when you're building a single page app, you're obviously going to make some API requests to the back end to get some data. And now, instead of using jQuery, because we don't want to use jQuery anymore, we have React, you can use, as I mentioned before, the fetch API that now exists on all of our modern browsers. So if you do window.fetch in your browser, you're now going to get a new API that can make, a new function that can make API calls. So the first parameter is the URL that you want to fetch to, and then optional options for it. So you can set the method, you can set the data that you're passing if you're doing a post, all kinds of different things. And fetch uses promises instead of callback functions to get the data back. So here we fetch, and then we get the response stream, and you can do something with the response stream. Or if an error happens, then you use the catch that way. So I've included a link to information on an MDN article about fetch, as well as a blog post I wrote about promises, because you're going to need to know promises in order to use fetch. And one thing to note, actually, is that all asynchronous APIs moving forward in the browser are going to be promise-based. So there won't be any more callback functions. Everything is going to be a promise. So learning promises, if you don't know, they came in, if you don't know them yet, they came with ES6 formally, is a good thing to know. The other thing you want to do in building a single page app is routing on the client, so that when people click around, you can still use the back button to go back to places, or they can bookmark certain places in the app. And with React, the most prominent one is React Router. I needed to have something else to compare, so I picked this other library, Aviator, but pretty much everybody uses React Router. They just launched their version 4 of React Router, but React Router basically uses the same JSX syntax for declaring your routes. So here we have the router component that's on the outside, and then you say you have your route paths. So this is the home, this is the repos, this is the about, and then you can just point it to specific components that you want it to render for each one of those routes. So it's pretty straightforward. And then when you want to link to a route, you just use a special link component that they provide, which is just a wrapper over an A tag that will do the browser history work for you. Okay, so now we've reached the asteroid belt. And at this point, the first 4 libraries that we've talked about are all you need to build an app. And really, if you haven't done any React development before, that's all you need to know. You need to know about React, you need to know about ES6, you need to know about styling, and you need to know about single page apps, fetch, as well as routing. everything now that I'm going to talk about is kind of extra icing on the cake sort of things. But one thing that's really important is testing. You can certainly deliver an app and not test anything, and the app will work, but it'll probably break. So testing is the next important thing actually after you've actually built it. And there are a number of testing options. You can use the combination of Mocha and Chai for testing. You can use Jest, which Facebook has created for testing React components, as well as just testing JavaScript in general. And there's another library called Ava, or Ava, I'm not quite sure which one it is, as well. So obviously Facebook, given that they built Jest, they recommend using Jest. And at Eventbrite, we recently switched from using Mocha and Chai over to Jest. And that's for something called snapshot testing. So you can imagine that trying to test what your component renders is not the easiest thing. And Jest makes it actually pretty straightforward to do. So all you do is you render out your component here, but not to a browser, out to an object. So it just renders it out to a JSON object, and then it does comparisons over the snapshot that was saved to the disk before and after. So you will save your component, it rendered to a JSON in your GitHub or in your Git account. And then the next time you run the test, it'll do a comparison, a file comparison of those to see if they're the same. So you no longer have to manually test, oh, is this class name the right thing? Does this have the right tag? Does this have the right contents? You just do an easy comparison of that. So I have more resources for you to read up about that. Oops. So I mentioned earlier about isomorphic React applications, and their purpose is to make things more performant and for SEO. So you want to render your app on the server side as well as the client side, because if you render it server side, the perceived speed for the user is much faster because it's already there, returned back from the server to render, instead of having to first load the page, download all of the JavaScript, and then render on the client. Having it rendered on the server is a lot faster. Plus for SEO, a lot of the crawlers like having the data already there to crawl as opposed to having to execute the JavaScript in order to figure out what the page is. So that's why you would render server side. And there are two ways you can accomplish it. The first way and the easy way is if you have Node on your server. So if you're running a Node server, you can just easily use Express. You can do fetches with Node fetch and then React router on the server, and it works just fine. But at Eventbrite, we don't have a Node server. Our backend is Django and Python. Or if you had Ruby with Rails or .NET and C#, you can't render those because those don't execute JavaScript. So what we ended up doing is we ended up creating kind of a slave node server that sat behind the main web server. So all it did was take inbound requests for a component it should render and then return back HTML. So the node server was basically a React render server. That's all it did, was render. Didn't take any public requests. So have a different talk where I kind of go into the details about how that worked and how we set all of those things up as well. Okay, so moving right along, the next big thing that everybody talks about is how to manage the data in your app. So once it gets bigger and bigger and bigger, you're going to have more data that's going to be changing all the time, and it's going to get complex, and you're going to need a way to manage that. And that's where the Flux paradigm, design pattern comes in. Has anybody heard of Flux before? No? Okay, one person. So Flux came about with React, and it's a different design pattern than MVC. So who's familiar with MVC? Yeah, okay. So that's the familiar way where you have a model, you have a view and a controller, and the view obviously renders the UI, and the model stores the data, and the controller kind of controls both of those too. But with the Flux design pattern, it's a unidirectional flow. So this is what Facebook showed when they kind of unveiled the Flux pattern, and I looked at it and didn't really understand what was going on, and it got explained to me 3 different times, and I still didn't know what was going on. It was just kind of a new way to wrap my head around how the transfer of data happened. So it's not important in this to go into detail about how Flux works, but there are a number of Flux implementations out there. So Facebook they came up with a design pattern and then ended up creating a JavaScript library that implemented that Flux pattern because there was such a high demand for it. But in the end, Redux became the library of choice for managing your data, your state with React. So it has a single store and has something called actions and reducers so that you can easily test and update your app state. So more than likely, so you can build a React app without Redux completely. Like, it's one of the first things that people end up throwing in their app in the beginning when they're learning React, and it's just a whole new mental model on top of React to learn the Flux design pattern. So I suggest just focusing on React and learning that first before getting into Redux. But if you are building an app, that's huge. If you're working for a company, you're going to end up needing something to store data. So Redux is pretty much the library of choice. It became so popular that Facebook hired the guy who wrote Redux, and then Facebook ended up taking in that library as well. And one other thing is, in React especially, you never want to mutate your data. You always want to make copies of your data if you need to add something to it or remove something to it. That makes React work a lot faster. But as a result, you're making lots of copies of data, lots of copies of arrays and objects. And if you have something that's heavily intensive and doing a lot of copies, your app can get really slow. So there are libraries that help with that, immutable or seamless immutable, so that when you're mutating your objects, they can keep objects that are the intersection of those two. So if you had an array and you wanted to add something to it, instead of making a copy of that 100-element array, it'll keep a reference to the 99 that were the same, and then just create one that's the new one. So it's this kind of when you have something that's really complicated, then you can end up using this, but more than likely, you won't need to use those libraries. And here I have an example of using them. So the last thing I want to talk about is API optimization. So a lot of times when you have APIs, you're going to make a request to a REST API, and you need like 4 pieces of data, but you get back 100 things that it gives you. So you want to know the information about LeBron James, let's say, and all you want to know is how many kids he has. But what you're going to get back is the team that he plays for, how many years he's been in the league, his age, all kinds of random things. And sometimes you're getting back a meg of data when all you need is a couple of kilobytes. So there are now some libraries out there that make it possible so that you can just request the pieces of data that you want. And there are 2 competing kind of ways to do it. There's GraphQL and there's Falcor. So GraphQL is something that runs on the server that sits on top of your database, and it's a JSON store, so it's a JSON interface. And there are 2 JavaScript APIs that you can use to talk with GraphQL, and that's Relay and Apollo. Relay was done by Facebook, Apollo was done by somebody else. And then Falcor is a competing way of doing the same problem as GraphQL, but it's something that Netflix came up with. So Netflix and Facebook at the same time were trying to solve the same problem and came up with kind of 2 ways of doing it. So Falcor runs on the server as well as the client. I haven't even used any of these yet. I just know that they existed because I haven't even had a need to build something. I've always been able to use REST, and it worked perfectly fine, but that's just something out there that you might hear about as you start doing React development. So in review, we talked about all of these things. React was obviously the main one, the important thing to learn, but then going down the line, this is kind of my opinion of the order in which you should learn these different things. Learn JavaScript and ES6 really well as well. And then tooling you're going to need, styling you're going to need to make your app look beautiful, and then so on and so forth down the line. So if you're interested, Facebook has actually come out with a lot of these libraries already. They've done React, as you can see in the upper left. Yarn that I mentioned, they also did that. Flow, Jest, Redux, Flux, and Relay and GraphQL. So Facebook is supposed to be a social network, yet they're churning out all of these open source software libraries as well. So it's kind of confusing as to whether they are a social network or a library. But they're generating a lot of things that us as developers can use. So for that, I'm very thankful for. And speaking of thankfulness, I'd like to end my talks by thanking different people. So first, I want to thank Devox for having me to speak with you guys and allowing me to share what I've learned, as well as Eventbrite for allowing me the time to come here and to share with you and supporting me in my speaking opportunities. And then lastly, thank you all for coming here and listening in. Hopefully you're able to get something out of what I talked about. The main reason why I like coming in and speaking to folks is I want them to leave, I want you to leave better than you came in. So having one thing that will make you a better developer than you were yesterday, and something that you can be able to apply to help you grow and become a stronger developer. So hopefully that worked out well. And with that, thank you very much. I think I have some time for questions if anybody wants to ask questions. Yes, what do you have?
JavaScript libraries and frameworks are famous for the speed that they move on at. So
Yep.
how long have you been using React? And honestly, how long do you think you'll be able to go on using it before it morphs into something else?
So I've been doing React development for a little over a year now, and React has been like strongly popular for probably 2. It's existed for 4. So I think the main reason why I'm kind of betting on React is because it's backed by Facebook, and they use it for their product. So it's all integrated into their app. So if they were to just throw it away, that would really hurt them. So it kind of has that backing of it. Do I believe that React will be around 5 years from now? Maybe, maybe not. But I think the development pattern is strong. So it will just morph into something else that hopefully we can move our code base towards. So JavaScript frameworks are a dime a dozen, like you mentioned. But I think there's a huge emphasis in the community to make it something that's useful to solve actual problems. Like Facebook created React to solve real world problems. So I believe that that'll continue to be the case. Yeah. There was a question over, okay. You?
Hi.
Yes.
Thanks for your speech.
Yep.
Welcome. I have a question about styling.
Mm-hmm.
And as I believe, React doesn't create shadow DOM, right?
Right.
So how does it style when you use component CSS?
Yeah, so you're responsible for doing all the CSS styling yourself with
No,
React.
I mean, how it, can you open the component CSS slide?
Yeah, so when you do component CSS, you have to maintain your own CSS.
I mean, collisions. How does it solve the collisions?
You have to solve it yourself with how you name the classes, basically. So in this case, I named.
So you can use the same CSS file to style different components, right?
You could, but I suggest that you have a separate file per component, but you have to have a naming convention to make sure that you don't have collisions.
Thank you.
Yeah. You're welcome. You can use the Shadow DOM with React, but you'd have to do it yourself. It doesn't do it automatically. Yes. Question?
I was went to your website, MVP. Very good.
Thanks.
Will this talk be on your website later, or is there a place where we'll be able to get this talk?
Yeah, so the slides are already on there on my website. So if you go, there's a speaking engagements page, and I have a link to the slides, or at least there should be a link to the slides there. But if not, I mentioned that I tweet out a link to them as well. So if you go to my Twitter account, BenMVP, you should see it there for sure. Yeah. Yes, in the back.
Why did you decide to go on the library approach? When you transferred from Backbone Marionette to React, why did you go to React?
Oh, yeah. So
Considering like the framework options for that Angular.
right. Yeah, so we knew that Backbone Marionette was not solving our problems. We were trying to create really sophisticated user interfaces at Eventbrite, and Backbone, we're just hitting the ceiling of what it was intended to do. Backbone was really an MVC library for managing your data, not for building sophisticated user interfaces. And Marionette was a library that sat on top of it to try to accomplish it, but it's not very component-centric. So if you're trying to reuse components and kind of compose them together, it wasn't meant for that. So then we started thinking about what are the other options. There's Ember, there's Angular 2, and React. Those are the main ones. And we decided to go with the React because we had familiarity in the team with the React already. And the community behind React was really strong. So there are a lot of people excited about it and a lot of just kind of groundswell around it. And I didn't feel like it would be changing drastically like Angular 1 to Angular 2 did because, like I said, Facebook is using it themselves. So that was kind of the motivation. And then all the positives of React in terms of the virtual DOM, diffing that it does. I feel like it's very easy once you learn how React works to actually write React code. So there are a lot of positives in that regard as well. Yeah. Any other questions? Yes. Yeah. So the major downside of React is that you have to create your own framework around it. So you can build user interfaces with just React, but you probably won't if you're trying to build something significant. So even here with this example with component CSS, you have to create that environment and how that's going to work. You have to create your own data store and how you're going to do that. So there are a lot of decisions you have to make to be able to create your React stack. So that is both a negative and a positive. If you know what you're doing, then you can really pick exactly what you want. But if you don't know what you're doing, you're probably going to pick the wrong thing and then be upset that you did it 6 months once you actually know what to do. So, and then there's just a big learning curve on React itself because it's a different way to program and to develop. But once you do learn it, I think it's okay. Yeah. All right. Well, if anybody has any additional questions, you can come up, talk with me afterwards if you don't want to ask questions in front of everybody, or you can feel free, if you think of something later, to tweet me or email me as well. Cool. Thank you, guys.